Okay, baby factoring. What comes out of both of these? X, factor it then. Make it fast. You're not going to have to write problems down, just write down answers. Okay, you should have said X comes out of both of those. X plus 2. Done. Now, if we just keep it that simple. Everybody show me what's on your iPad right now. Okay. Good, thank you. All right. Now, in these, the answers, no, this is factored, but what are the answers or the solutions, the roots, the zeros? What are they? All right, 0 and -2. You take this part and you set it equal to 0. You take this part right here and you set it equal to 0. And then this one comes out to be subtract 2, x equals -2. This part's x equals 0. 2 answers because it's got a squared in it. Does that make sense to you? Were either of these imaginary answers? What if it had been like this? Would either part be imaginary? No. Nope. All right, would everybody right now tell me this one's answer really quick? -3. That part, would you write it all the way out? Start by saying x squared minus 3 equals 0 and solve it. It's a very common misconception. And I also led you the way I was asking the question to say yes, but I wanted to see if you'd really think. X squared equals 3. You see how I'm not going to have a square root of a negative when I'm solving it? It's a square root, but that doesn't make it imaginary. It would only be if that square root is negative. Square root. X equals square root of 3. Wrong. What did I forget now? Plus and minus. Now, does it make sense? I hope it does. There's 2 answers for this. See, it's got a little square in it. There shouldn't be 2 answers. Okay, this part only had 1 answer, and the answer was -3. All right, another common misconception. You're the math teacher, and your kids keep telling you that the answer, let's say that's it, so that they'll say, okay, the answer for this one's -3, and the answer for this one's +3. There's my 2 answers, -3 and +3. Do you get what the kid is doing? What is the kid doing when they do that? They're doing it wrong, but what are they doing? Yes. Yeah, they're only looking at these and saying, oh, it's the opposite of that. But if you actually put in -3 here, it will make it equal 0. If you actually put in 3 here, it will not make it equal 0, right? It'll make it equal 6 minus 3 would be 3, right? It would equal 3. It won't equal the right thing. Okay, so the point is you're supposed to take both sides and set them equal to 0. So this kind we usually just shorten up and say, well, the answer is -3. But really what you're doing is set equal to 0. And now x will equal -3 when you solve that. Set this equal to 0, and then you'll have x equals 3/2. Halves, right? Okay. Do you get what I'm talking about there? Don't just assume that it's the opposite of whatever this is. Take the whole thing, set it equal to 0. Okay, next thing. When you get this kind, think divide and conquer. Divide and conquer. That's the time where you say, nothing goes into everything. So I have to divide it up in 2 parts. 2 first steps. See what comes out of it. Uh-oh. This one will divide and conquer, really. sure this is going to work? Okay. Oh, yeah, it does work. Okay. Okay, negative is negative. This would be a plus. And then it, yeah, it's a, okay, yay. Sorry about that. No. Okay, what do you got left? These x plus 8s come out front. And then what's left underneath? There we go. Raise your hand if you had it right. Okay, good. That was factoring again. Could I have done that? Another code. Yep, you could. Since you're going to have a graphing calculator for this entire test, give me a graphing calculator way you could have done this. Yes. Yep, and when you, yes. And where would it have touched? At -8 or 8? Think about it. It would have touched at -8. I want you all to graph this right now. On your calculator, graph this, the big blue one here. If you need to borrow one of mine, no problem. Just make it fast. Some in the drawer here. It's too bad. I didn't find any, so... All right, once you graph this thing, I think you're going to find two of your answers are going to be decimals. They're the ones that go with that x squared minus 10 part. But one of your answers should be -8. Do you see it touching that? I'll let you take a second. Finish graphing it. Take a graph. Bring it up. Okay. There, now I'll make more sense. Okay. All right. When you're looking at the graph window, it might be really hard to see the big picture of what this thing's doing. If you zoomed way out, you might be able to tell. But the main point is, did you get that it touched way over here at 8? Now, there was a spot over here that it touched at, which was the square root of 5, and another one that it touched at, which was the negative square root of 5. Do you get that? Or was the square root of 10, was it? Maybe square root of 10. How would I do that? I go x squared minus 10 would equal 0, x squared equals 10, and now I square up both sides, and I get absolute value of x equals square root of 10. Yeah, it's the square root of 10. And x equals plus or minus the square root of 10. So these two, the square root of 10 ones, you wouldn't have known exactly what they were. But the other one, it should hit right on the line, and should hit right at 8. And if it hits right at 8, then you know 8's one of the roots. Or -8, sorry. So my point is this. Now you've graphed it, and you see this thing that touches at -8. Let's go back to the beginning and say, how could I have solved that equation now that I know that it touches at -8? What was that other method we used then? Synthetic. Would you all, right now, put in -8 and do synthetic on that puppy and show that that would have worked too? It still will get you the same answer. -1, 8, -10, -8. I was coming back from the Wisconsin Dells this weekend. It was fun at the Dells, but then, oh man, Sunday was a long drive home. Oh my gosh, it was pretty awful. Was anybody else driving on Sunday? Where were you coming from? Oh, yes. They didn't warn you in time. All right. Drop this one. Multiply. Add. Multiply. Anyway, 0 times anything is 0. Add. Multiply. Positive 80. It worked. And then remember that the answer is x plus 8. And then all of this gets in a parenthesis. And this is x's and this is x squared. There's 0 x's. That's important. And now I'm left with, this up a little bit, housekeeping, x plus 8 and x squared minus 2. Just like we got before. See? You could do it this way, you can do it that way. But when you get to the big boys, divide and conquer won't work. Because you need to have synthetic to handle ones that have like 5 terms. Alright, I want you to put in a different equation on your calculator. Let me see if I can find it in previous work that I did here. This one. Alright, everybody type in this one right here. And wait a minute, we don't need that plus 0 at the end. When you're graphing it, your calculators can handle stuff that's missing like that. Just graph that one right now on your calculator. Alright, here's mine. When you hit graph, I had to zoom out a little bit, I think, and then do a zoom box. Let me show you what I did there, just so you, because when you hit zoom 6, you can always start with that. That's the standard zoom. It's kind of hard to see exactly what's happening, whether or not they're touching at whole numbers or decimals and stuff. That's the zoom 6, that's a normal zoom. Okay, so now how do I tell for sure? I would zoom box it. Zoom box is number 1. There's one more zoom I'd like to try. Maybe I'll try a zoom, not a zoom trig. Zoom fit is sometimes cool. Zoom fit. Let's see if I like results there. Ooh. I can see it bouncing at that one root really well. That's kind of cool. It's not perfect. It's kind of hard to tell where it's touching, but at least it shows more of a curve. Alright, I'm going to go back to zoom 6 again. And then I'm going to zoom in on the part that's really important, which is right through here. So how do I zoom that? Zoom box it. Make a box just like that, the zoom box. If you'll do. Zoom box. Now, the first thing you got to do is move the little thingy. It doesn't know where you want the box. You got to move the little thingy until you get to where the corner of your box would be. And you hit enter once. Then you make the rest of the box by arrowing to the right and down. You can even start with the other corner first if you want. There. So you got that puppy zoomed in. It's way easier to see that you got a bounce happening. And it's touching here, which is a decimal, and here, which is a decimal, right there, which is at 0, and right there, which is at -4, and it's a bounce there. No, a bounce means that it's a double root there. So there's a double root there of -4 twice. What does that mean? When I factor the thing, I'm going to have an x plus 4 and another x plus 4 when it's all done. So I know there's 2 roots here. I can do either one of them for synthetic. What do you want to do? Do with the -4 or the 0? All right. Let me show you something about the 0. It's kind of cool. It's kind of important. If I ever have 0 as a root, look at this problem. What's special about it? There's no constant. They all have what in them? That's what it means if 0 is a root, is that they all have an x in them, and you can factor that out. Do you get what I'm going to do here? I'm going to factor the x out. I'm going to have to not do synthetic. It's way faster. You could do synthetic with a 0, and it'll just be like this. X to the 4th plus 8x to the 3rd plus 14x squared. Notice I'm just taking x off everything. Minus 16x minus 32. See? That's what would have happened if I would have used 0 for a root. Do you get why? Because see, that x could be like x plus 0. Right? X plus 0. See? All right, so I factored that x out, and here's what I get. Next thing, I did, what do you call that? Starts with an S. Synthetic. And I factored it. And then look what happened next. I could take this answer and divide and conquer it. And so I had my x that I took out originally, then I had an x plus 4, and then when I divided and conquered, I ended up with an x and an x plus 4 and another x plus 4 and an x squared minus 2. And then you find the answers for all of those. This one's 0, this one came out to negative 4, this one came out to negative 4. This one took a little more work, and I came out to plus and minus the square root of 2. I have a total of 2 answers for this, plus 3 more answers, makes 5 answers. And that's what the original problem had, 5 answers. See what's going on there? All right, that was problem D as in dog on your worksheet for today. Everybody look up problem C as in cat, the one right before that one, on your worksheet for today. Raise your hand when you've got it. Oh. All right, would you read yours to me, please, Jack Bro? Yes. Read me C. All right. This is really tough factoring. This is the hardest factoring you will ever do. Like, this is harder than they do in calc. In fact, a lot of schools, kids would never learn how to do this. All right, so how do you do it? I don't know. Can I do the divide and conquer thing? Nope. But you do that when you have 4 terms. Technically, you can divide and conquer on some sets of 6 terms because you can do 2 sets of 3. Okay? But don't even bother. Yep, in theory you could. But it's weird. We're just going to do that on ones that have 4 terms. This one, graph it. Because once you've graphed it, you'll see where the roots are. All right, everybody, go back, type that puppy into your calculator. We'll see if it has nice whole number roots. Can you just type this into your calculator? It's not that hard. Okay, good typing. I'll type it too. We'll share the pain. We gotta remember it's x to the 5th minus, because I'm covering up the rest of it. Minus 5x to the 3rd. Squared. Minus 6x plus 8. Okay, looks like it touched 3 places. How do I get the better view of this? $2. I'm gonna double check my graph because I see people squinting at my answer. Oh, yep, I was at one of my numbers off. X to the minus 3x to the fourth. Now I gotta insert something. Second insert right by delete. Gotta insert a negative 3x to the fourth. Somehow I messed that up. Negative 3x power of 4. Positive 5x. Oh, believe it or not, your calculator is way better than my computer. Because my computer is so slow and I try to arrow over to make changes and stuff. X plus 18. Okay, graph. Whew. Okay, I'm going to zoom box. That was not what I was expecting to see. See if I box in that area, it'll work nicer. Oh, sorry, my calculator's giving me major issues here. I don't know why I put parentheses around that. I never have seen that before in my life. I bet you're right. There. Oh, finally. All that work. Now at least I know it touched at -1 and +1 because I saw them go through right here and here. So now, all I really needed to know from all that is that -1 and +1 are roots. Now I can do synthetic on with a 1 or a -1, either one. Why don't we just pick one? Did any of you guys start already? All right, we'll do 1. And it's 1, -3, 5, -15, -6, and 18. Drop it, multiply it, add it, multiply it, add it, multiply it, add it, multiply it, add it, multiply it. Wait a minute. Ah, that right there should be -18. You're right because you're adding them right. There we go. There we go. And now that makes that -18. And then they will make 0. Yes. So, here's the other thing that's really important and cool. Now that I got this big, huge thing factored, I don't have to regraph this thing. Because you remember how I found 2 roots right away? One was -1, one was +1. Which one did I already use? The positive one. Now I can use the negative one. Because I know it's going to, -1's going to work. So I've already used +1, I'm going to use -1. Yep. So now I'm going to do synthetic on this. 1 goes here, the -2 goes here, 3, -12, -18. Draw the line. If you haven't already, please do that now. And then I think you can divide and conquer. And the next around to check on you. Okay. So a lot of people forget this. This x minus 1 has to come down. And this one is our new one. And it's x plus 1. And then this is that answer that I haven't done yet. I better do that. So I'm going to drop this one down here and make it a 1. 1 times negative 1 makes negative 1. Add these together makes negative 3. Multiply them, positive 3. Add them, 6. Multiply them, negative 6. Add them, negative 18. Multiply them, positive 18. It worked again. And now I've got my new answer of this is an x, this is an x squared, this is an x cubed. Do a little sign in between those two. There we go. And now you can divide and conquer on this part. If you haven't already done that, do that. Get your final answer. That's how hard some of the questions are on the test on Thursday. You got to do 2 layers of synthetic and then 1 layer of divide and conquer. And when it's all done, then you have to take your answers and find the solutions to them. On the ACT test, and the SAT test, that's real life. Now, this is one of those ones where it is definitely harder than average math. So it all depends. If you want to be a shepherd, you don't need this. Some of you might decide, you know what, shepherding sounds pretty good right now. I doubt the Octo Mom has ever done this. The Octo Mom. You can be a reality TV star if you want to do this. What? Yes. Okay. That was when I was doing synthetic, remember how it has to end in 0? 0 remainder? Yeah. So now, this comes down. This comes down. This part, I'm going to do in green, the divide and conquer part. X squared went into both of them, and I have x minus 3. And then, that's a, should I take out a 6 or a negative 6? Try 6 and 2. X minus 3. Hey, that's what I want. Now they're the same, that and that. So then, I put the x minus 3 in front, and then I have x squared plus 6. And this is a really good problem because it's got real answers and imaginary answers. And you had to do all different kinds of factoring on it. All the kinds you'd need for the test. There you go. There's your big final factored answer. But it isn't the solutions yet. The solutions are easy though for the first 3. These are all real numbers and they're just like, well, how would I make this equal 0 if x was 1? How would I make that 0 if x was negative 1? How to make that 0 if x is 3? And the last kind I have to actually do because I can't do this in my head. Set it equal to 0, then x squared is equal to 6, and then from there, can some people do it in their head? Yeah, you can. It's okay with me if you show me this much work, and then you want to jump down to x would be plus or minus is the big thing a lot of people forget. Square root of 6. Oh, and you know what? I screwed up my equation at the beginning. You see, right here it was wrong. What was I doing wrong? Forgot the negative right there. That's why I screwed it up. Okay. And you know, this happens so often. If I try to skip over 3 steps, I make a mistake. It'll happen to you too. Try not to skip too many steps. I'm not saying you'll never do it right sometimes, but you make more mistakes when you skip steps. Square root, absolute value of x is square root of negative 6, which I'm going to say is I root 6. Now I can do my last step, which is make this plus minus I root 6. Holy cow, those are imaginary roots. Real. Total of 5 roots. 3 plus those 2 makes 5 roots. If I look back at the original problem, it had a 5 in it. So all those things match up. Do you see how if somebody at the end could have forgot their plus and minus? That happens a lot. And hopefully they'd notice it here. They'd go 1, 2, 3, 4 answers. And then they'd look back and say, wait a minute, it's supposed to be the 5th. It's supposed to have 5 answers. And hopefully that would make them go, oh yeah, that's right, this one counts for 2. There's a plus and a minus. Okay, that's kind of everything you have to know. Okay, it's as hard as they would get. Are there any of those parts that you'd like to get some more help on or whatever? Yes? The worksheet B, yes? Possible what? Possible roots. When you graph it, that's the way we're showing you how to find those possible roots. Remember when we pulled up our graph and we found that it touched there and there? That was at -1 and +1. That was your possible roots. Now, there is another way, but we're not testing you on. The other way is using that rational root theorem, which I'll just remind you, you don't have to do this for the test, but you just have to say, what are the factors of 18? I guarantee you the roots that we came out with are going to be related to this. Okay? And it ends up being the roots of 18 are 1 and 2 and 3 and 6 and 9 and 18. Okay? Then that means that the plus and the minus of all of those things are all the things that kids would have had to check last year. Imagine how much harder this would be if you couldn't graph it and to find out what to use. See, they had to check every single one with synthetic and see which ones worked. Just we didn't allow them to use their graphic calculator for it. But this year we decided that that's probably more like what you'd do in the real world if you had a calculator sitting there. Now, you can't use Google when you take the ACT test, right? But you can use your graphic calculator. So we wanted to show you, here's how you could use the calculator to do it. Yes? All right, to find the y-intercept. The y-intercept for any equation, go back to the original equation, and you ask yourself, the y-intercept is where what? So I could put a 0 here, and here, and here, and here, and here, and all of those cancel, and the answer is 18. Okay, so the y-intercept is just cancel off all of the things that have an x in them. Because you make x equal to 0, and it'll make them all disappear. All right. I think that's enough. I want to give you a lot of time to work today. And that way you can ask me individual questions. If you're like, I'm not getting this part of the worksheet, this is a good time to ask. Got like 20 minutes left. Okay, your assignment is to take the worksheet B, the same worksheet you did before, and you only did 2 parts of it. Now you have to go back and do all of it except that rational root theorem thing at the very beginning. Okay, because that part we're just going to graph the calculator. So the very first part, part A, you can skip. So basically, you already did B and D, so I think they're pretty much in section C. But when it's all said and done, the worksheet has to be all done except for the very first section, part A. All right? And that's your homework.